Hey guys, this is Chem with Kate, and in this video we're going to be assigning chirality to Fischer projections. In our first example, it's clear that we have only one chiral center, so let's start with that central carbon. Now remember, when drawing Fischer projections, all horizontal lines are representative of wedge bonds, bonds coming out in space towards you, while all vertical lines are representative of dashed bonds, bonds going away from you in space. And when assigning chirality, we only go one atom at a time. So I'm only going to draw the atoms directly attached to our central carbon. On top we have a carbon, on the bottom we have a carbon, on the right we have a hydrogen, and on the left we have a chlorine. So we can begin assigning our priority. Chlorine will have first priority. Now, because these two carbons basically tie, we can go out one more step to the atoms directly connected to them. So on this top carbon, we have 3 hydrogens. On this bottom carbon, we have a hydrogen, and a carbon. And then one by one, we can evaluate these atoms and see which one has higher priority. This hydrogen will cancel out this hydrogen. Same thing with this one. But this carbon will win over this hydrogen. Therefore, this has second priority, this has third, and the hydrogen alone has fourth priority, the lowest priority as expected. Now going from 1 to 2 to 3, it appears that we're going in a counterclockwise direction, giving this an S configuration. But this would be incorrect. Because remember, on Fischer projections, horizontal lines are indicative of wedge bonds coming out towards you. That puts our lowest priority group closest to us. And we know when assigning chirality, our lowest priority group has to be farthest away from us. So we have to reverse our chiral center, and this is truly an R configuration. For our second example, we have a molecule with 2 chiral centers. We're going to evaluate them individually, starting with the top one. We'll write down that central carbon. Now remember that on Fischer projections, the horizontal lines are indicative of wedge bonds, meaning they are coming out towards you in space. We have a hydrogen and an oxygen. And the vertical lines on a Fischer projection are indicative of dash bonds. On those, we have a chlorine and a carbon. Now we can assign priority, one atom at a time. Chlorine has first priority, followed by oxygen, carbon, and hydrogen. Going from 1 to 2 to 3, it appears that we're going in a counterclockwise direction, giving us an S configuration, but on closer inspection, this would be incorrect. Did you catch that this hydrogen was on a wedge bond? Our lowest priority group is currently closest to us, and that cannot happen when you're assigning chirality. So simply choose the opposite, placing the hydrogen, our lowest priority group, in the back, giving us an R configuration. For our second chiral center, we're going to do the same thing. Start with that central carbon. We're going to evaluate this one atom at a time. Starting with the horizontal bonds on wedges, we have a carbon and a hydrogen. On our vertical lines, we have a dash bond indicating a carbon and a carbon. Since we have 3 atoms connected to the central carbon that are all the same, we're going to have to go out further one atom at a time to evaluate priority. On this top carbon, we have 3 connections, a chlorine, a hydrogen, and an oxygen. On this side carbon, we have 3 connections. We have a hydrogen, and a hydrogen. And on this bottom carbon, we have an oxygen, and an oxygen. Remember, in reality, a carboxylic acid functional group has a double bond to oxygen and a single bond to an OH. But when assigning chirality, we treat this double bond as 2 single bonds. So going through to assign priority, all of these carbons are the same, so we move out to what is connected directly to those carbons. And out of all of these atoms, the highest priority is this chlorine, giving this entire group first priority. Moving on to this group and this group, we have oxygen against hydrogen, oxygen having highest priority, making this number 2. Now we can go back to this carbon versus this hydrogen. This carbon has higher priority, making it group 3, making this lone hydrogen group 4. Going from 1 to 2 to 3, it once again appears that we're going in a counterclockwise direction, giving us an S conformation. But looking closer, you can see that this is also incorrect. This hydrogen is still on a wedge bond, and it is our lowest priority group. When assigning chirality, the lowest priority group must be in the back, so we can just choose the opposite chiral center, giving us an R conformation.